Welcome to part 4 of the project tutorial. So far we've been developing the Battleship game, adopting a top-down, high-level to details design approach. So we thought conceptually about the different classes that are involved in this game, what kind of attributes, what kind of information belongs to each class, and also what kind of actions, what kind of methods each class will implement. So far we've been working on a couple of these classes, including game, which is the main class that drives the game, right? And we've got also classes to model the player, the ship, the board. So what I want to do now, I want to go back to that uh, specification of the problem and see if we can make some progress toward the final goal, which is delivering this project. So this project has two deliverables, and the first one is basically to get the players to place the pieces on the board, and then printing the two boards out. Of course, this is just because it's for testing purposes. In the real game, you wouldn't print the two boards because this will disclose the other player's board. Now, deliverable 2 is about playing the game itself. So the players need to take turn, and the game needs to decide whether it has ended or it needs to proceed. So what I'm going to do now, I'm going to work towards deliverable 1. So let's see what we did last time. Let's go to the class game. So the class game is where we have the main method, and the main method the game starts basically by asking each player to enter some information basically about the two players, but then each player will need to initiate their own board, and then the two boards will print out. So this is basically deliverable 1. And then we have the main loop, which is basically the two players taking turn, and this is deliverable 2. So now adopting the same strategy of the top-down, kind of fleshing out the details step by step, I'm going kind of to tie some loose ends toward achieving deliverable 1. So in deliverable 1, notice that um, each player needs to initiate their own board. If we go back to the initiate board, init board method, we can see that right now it's just creating a random state, a random board, and we have a to-do note to fix this, because the two players need to initiate the boards by placing pieces on them. Okay, so what I'm going to do, I'm going to start thinking about how we initiate the board, and I'm going to try to come up with an incomplete implementation and then work on the details later on. So of course in this game you notice that there are two players. One of them is a human player, and then of course there is a program, the computer playing the game. So those two players initiate the board and also make their move in different ways. The human player will be entering the location of the pieces via the keyboard, while the program will need to make these decisions by itself, right? So we have to encode that in the program. So, and again, if you look at the sample run, this is kind of reflected here. The human player setting their own pieces is being asked to place a certain ship, being given options to rotate the ship, and then once they enter the coordinates, the ship will be placed and the board will be printed. Okay, and then it will proceed to the next ship. Now, if you scroll down to the end where the human player has done setting the pieces, the computer player is being asked to set its pieces. It's doing this automatically, right? And then the two boards are printed. So we need to think about this distinction between a human player and the computer player. And this distinction is right now encoded in this Boolean attribute called isHuman. Okay, so let's go back to game, and we have two players created, right? Player 1 and player 2. So then we need to ensure that before we start the game that player 1 is human and player 1 is not human. This is only from an information perspective. We simply need to record this to state the value of this attribute. So what I'm going to do, I'm going to call the method set. So player 1, game, after creating game, because player 1 belongs to game, it's an attribute of that game, player 1 set. So we need to make isHuman true, right? And it looks like we don't have any setter method for isHuman, and that's why we can't set that attribute. So what I'm going to do, I'm going to provide a setter method is set isHuman, Boolean isHuman, and I'm going to set isHuman, the attribute, to be equal to that parameter passed to the method. So again, this is one detail that we haven't thought about, and it kind of emerged, but it's a small detail that we can kind of finalize on our way to achieve that working on the solution. So right now we can set isHuman, and of course player 1 is human, and we do this to player 2, and then we set it to false. So right now this doesn't change how the current program works. It's just setting a flag in each instance in player 1 and player 2, right? And what I want to do, I want to use this flag down the road when the two players are initiating their own boards. Because if the player is a human, it needs to be kind of an interaction. If the player is not human, it needs to be an algorithm to set the pieces. So what I'm going to do, now that I have set these two attributes, I'm going to go to the method initiate board in player, and what I'm going to do, I'm going to see if I can make use of that attribute isHuman. So what I'm going to do, I'm going to create a stub saying if the player is human, then it will do its human things. So system out print line, maybe thinking, or maybe initiating board by thinking. Otherwise, we will do initiating board by computing. All right. Again, this is just a step to see if the overall effect is here. So when I run the game now, so I'm going to enter my name, the opponent name, and let's see what happened. So the human player is initiating their board and initiating board by thinking, and AI is initiating their board, initiating board by computing. Okay. So this is now an opening to ensure that the implementation of the method will differ depending on the kind of player, right? A human or not a human. So right now you can think that instead of this system out println statement, we can implement the logic of initiating the board with a human player here, and we can implement the logic of initiating the board with a computer player here. What I'm going to do, instead of kind of typing all of this in this one method, I'm going to create two helper methods and call them from here, right? So instead of doing complicating init board, I'm going to kind of spread the responsibilities to two other methods, and I'm going to call these methods think and compute. Okay, so instead of printing this line, oh, we'll keep this print line, and then we will clean up this after we finish kind of the implementation. We'll keep this kind of as a kind of a bookmark, a flag that it's doing something for humans. So I'm going to do think. Okay, and then here I'm going to do compute. All right. So initboard then will delegate responsibilities to either one of these methods, depending on whether this method is whether the instance is a human, whether is human is true or false. Now you may ask me, so why it's think and there is no object, right? It's a method call, so it has to be object name dot method name. So that's true, but this is the same object we're operating on. So the same object which is initiating the board will call think. So this means that we don't need to use an object name, but if we insist, we can do this dot think or this dot compute. But again, it doesn't make a difference here because it's the same object. Okay. Well, the second question here is like, well, void think and void compute, where is public? Well, of course, we can make the method public, but I'd say I'm not going to make it public because it's an internal method which is not supposed to be called from the outside. It's doing some work internally, so it's for internal services, internal calls. It shouldn't be called from outside. From outside, you call initboard, and initboard will decide whether it's calling think or compute. So I'm actually going to make it private rather than public, right? So this is like a detail that we want to hide to the outside of that class. All right, so right now we have two loose ends to tie. One of them is to finish the method think, and the other one is to finish the method compute. So how do we place items on the board? Of course, in this game we have ships, right? And the ships will need to be placed on the board, and each ship has different dimensions and different shapes. Now, conceptually, you can think about placing ships on the board by switching the values of individual cells. So the individual cells are initially all empty, they're all open water, but when a ship is placed, some of them will be turned to be a ship cell, depending on the ship shape, orientation, and location, right? So essentially, it boils down to something very similar to tic-tac-toe, because you've got this two-dimensional array in board, and this two-dimensional array called cells, and each cell can be either an OpenC, a ship, hit, or miss. So we can think about this across the lines of the tic-tac-toe game, and we can try to implement think and compute initboard by trying to modify the values of the cells in the board, right? So let's do this, and of course each player has two boards, and each player will need to operate on own board because enemy board is initially unknown. It's all OpenC, and the state of this board will be unveiled over the course of the game. So what I'm going to do with think, I'm going to try to interview the player to set the pieces. So, and again, as a guide, I can take a look at how this is operating. Player name, please set your pieces. And then place this ship, and so on. So here's what I'm going to do. I'm going actually to take out this since we've just took a look at that. And I'm going to probably change this to match the output. Again, it's not a big deal here because this is a game, but I'm just going to make it match the output. And now I'm going to look at the method think, and the method think kind of going over all of the ships and asking the player to place a ship, enter coordinates, and then they enter coordinate or rotate, and once the coordinates are entered, the ship is placed. So there are a couple of things in here. First of all, where are all the ships? And there's also the question of rotating them, and of course placing them. Not to mention that we need to do some verification so that the ship can, the input needs to be valid. For instance, the location should be a valid one, otherwise that input is not accepted. Okay, so that's also important to note that we need to do some input verification as well. So many things to think about at the same time. The approach is to simplify the problem and work on subproblems. So I'm going to work on one of the subproblems, which is placing the ship. But then we need to think about the different kinds of ship and also rotating the ships and also validating the input. So here's what I'm going to do. I'm going to say, I'm assuming here that each ship, so all ships are the same, right? Of course, they're not the same. They are 1, 2, 3, 4, 5, 6, 7, 8, 7 ships, 7 different ships. Let me simplify and assume that each ship basically is one of these squares, and I'm going to place those squares on the board. So this is like placing tokens on a tic-tac-toe board, and this is what I'm going to do. Let's assume that all the ships are the same, and then we're going to ask the player to enter coordinates of these ships, of these squares. So then it's basically going from 1 to 7, because we've got 7 ships. And I'm going to do system out print line or print. And here I'm going to copy paste that enter coordinate column row or -1 to rotate. For some reason this is starting with a column, so that's fine. What I'm going to do, I'm going to read the column and the row from the input. Of course, we need a scanner object to do this. We don't have one. We have two options here. Either we create it in the method or we create it inside the class. I'm not so sure yet if I will need it elsewhere. Probably I will need that scanner object in order to shoot, because shooting will also depend on entering coordinates. So to make this scanner shared across the two methods, I'm going to create it here. Okay, so that's that. Of course, we need to import scanner. Okay, so next I'm going to call scanner next int and column, row scanner next int. Now what I'm going to do here, I'm going to put that to do that, we need to check for valid input within the dimensions of the array. Assuming this input is valid, what do we do with it? If this input is valid, we need to place that ship on the board. So right now, we're assuming that the ship is 1 square, but this needs to change at some point when we implement the class ship. We haven't implemented the class ship yet, so for now I'm just focusing on the logic of placement. So what I'm going to do, I'm going to say, well, this .onBoard needs to reflect this this new change, right? At column and row needs to change to reflect the fact there is a ship. So what is this .onBoard? It's basically a class, or it's an instance of type board. So of course it doesn't have, you can't index it because it's not an array. There is an array inside it called cells, but we can't access cells because it's private. So what I'm going to do, I'm going to go to the class board and provide a method called place token. Very similar to the method place token that we used in, we'll call it place ship because there are no token here. It's placing just a ship on the board. And this one will take a row, column. At some point we will need to think about how we are passing that ship object. For now we don't have a ship object, but I'm going to provide it still for the future. So providing this ship on row, column, and probably we need to think about orientation as well. So I'm not sure about orientation still, so I'm going to keep it as an open kind of end here. And I'll return true. And what I'm going to do, I'm going to change cells, right? Because this is the array. This dot cells, row, column would be equal to ship, right? So ship. And then we return true. Of course, it seems to me now that we can validate very much like what we did in tic-tac-toe. So I'm going to move those two comments here that you need to validate that this is an entry, a good entry, a valid input for the cells. So what I'm going to do, I'm going to do place ship, and I'm going to pass row, column, and then I need to pass the object for ship, which I don't have yet. So of course there are different ways to do it. Let's say for instance ship P, I can create a ship and I pass it. So this is just like an instance with nothing inside it because the class ship, well, there's X and Y, they will be 0, right? So I'm just passing it, but we need to think about the details, kind of flesh out the details at some point. Okay, so that's it. We place the ship. Oh, of course, deal with incorrect input because this method will return a valid, will return a Boolean value whether that selection is valid or not, right? So let's leave it to later. And again, this should be very similar to that tic-tac-toe example. But so far, this loop will go from I1 to 7, so 7 times. And each time we'll ask the player to enter column row or -1 to rotate. And of course, if it's -1, we need to think about rotating. So think about rotating. But for now, it should at least work for placing squares, ships of type squares on the board. Okay, so let's wait and try. Here we go. Please set your pieces. So it's going to say, well, enter coordinates, column and row, so 1, 1. Because I don't want to think, I'm going to do 4, 4, 4, 5, and 6, 5, 0, 7, and 8, 9, and 4, 4. So let's see. And now you can see that there are a couple of tokens being placed on that ship. Okay? Sorry, on the board. So those tokens, each one of them represent a ship. So that's a partial implementation, but you can now work incrementally on finishing out the details one by one. Okay. Now, it seems to me that those should be OpenC. For some reason, we left out initiating or filling out the board when it's created with OpenC values. So let's go to board and see if we can improve this. So this is where this is created, right? Cells is created. And right now we want to fill those empty cells with those tildes, the value C. The question becomes then, where is the good place? Where is the method where we want to make this change? And if you look at the board, you can see there are a couple of methods: print, place, ship, randomize. But those methods will be called at different points in the program. And more importantly, none of them will be called automatically, right? So we want still the board to come up with a default state, which is all OpenC. So this is where a constructor is very helpful, because a constructor is a special method that will be called automatically whenever the object is created. So what I'm going to do, I'm going to create a constructor for the class board, and the constructor will share the same name of the class, and it doesn't have a return type. And what I'm going to do here, I'm going to say, well, for each row, for each column, the cell will be C. So from I0, I is less or equal to cells, which actually rows, right? So I don't need to do cells here. I++, and then I'm going to do J. J is less than columns, J++, and then cells IJ will be OpenC. And this constructor will be called right after we create the instance of board. So when are we creating that instance of board? It's actually created when the instance of player is created. And when is this instance created? Is created here. So you'll notice here that the moment we create a new player in game, we've got those cascading creation. So we create a new game, the game will create a new player, the player will create a new board, and then this is where the constructor will be called. So it's fun to see that cascade, so let's step into this execution here. Let's see what happens when we create a new game. If you step into a new game, you can see that we're here, we create a new player, so we go to the player, and if we go inside the player, it's going to create its own board. This first step is kind of a Java thing, so if you go into board, you can see right now that we are calling the constructor, and the constructor will basically initiate the state of the board. So of course, we've got those three creations, and then it goes over each cell, each row, and so on, right? Once this is done, let me skip to step out, skip that method. You continue creating the player. Of course, we'll create the second board, the scanner, and then it goes back to game, and then it goes back to main. Okay? So this is the sequence of creation, because the player is nested inside the game, right? And the board is nested inside the player. We need to create the game that will create two players, and each player will create two boards. Okay. So right now, the board will start with an OpenC. It should start with an OpenC. Let's try that. For the lack of creativity, 3, 3, 4, 4, 5, 5, 6, 6. And this is my board, right? Ship, 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 and the rest is OpenC, and the AI's board is all OpenC. Okay. All right, great. So the human player is kind of initiating their own board with so many details to flesh out in the future. Following the same approach, I'm going to work on the computer player, the AI, and see if I can do the same idea. We need to use compute. How does the computer player places the ship? Well, of course, you need then to think about an algorithm. And the algorithm basically needs to figure out how to place the ships into the board. So this is not a straightforward problem, because it becomes harder the more sophisticated you want the algorithm to be, right? If you want a true AI, you need to think about a sophisticated algorithm to place the ships. What I'm going to do now, I'm going to simplify things to me, and I'm going to assume that you've got the most naive computer player to play against. What's the most naive approach to place the ships? Well, one of them is predetermined. It always selects same locations and places ships in these locations. That's the most naive approach. Probably a better one is to place those ships randomly on the board, so you get out with a random placement. And this random placement may not necessarily be good because you're supposed to space out the ships and not to put them together in the same place. But anyhow, we will start with a random placement and think about improving it later on. So what I'm going to do here, I'm going to take a line from think and create the loop that goes over 7 pieces. And thinking about getting the column and the row here. Of course, the column and the rows were created by reading from the input. How does the computer player decide about column rows? Well, instead of being created from the input, we're going to generate those numbers randomly. Once we generate these numbers randomly, it's the same story with the same loose ends, because we need to double check that this is valid input. If not, we need to generate these numbers back again, right? Same loose ends to finish, same details to flesh out. The key in here is just we are kind of doing this in parallel, right? Thinking about how we generate numbers from the user, reading them from the computer. A random number generator will be kind of a first choice, right? If you don't want to make it very sophisticated. Well, of course, rand does not exist. We should have an instance of random number generator. Again, same choice. I can make it here or I can make it up here. And I think making it an attribute is better because I'm thinking along the road, I will need it also for shooting. Let's say your algorithm for shooting, for instance, starts by randomly targeting different locations in the board. And then once you hit a ship, probably you want to target a smaller area around that ship to sink it. So that's it. I'm going to create my random number generator. And because this is an attribute, it can be accessed in any method. Of course, I need to import that class. Otherwise, I can't use it. All right, so that's it. Compute and think in parallel. The only difference is using scanf versus using random. And again, you can see that the good naming convention that the system library developers use is making things easy on us because nextInt is the same method name in both classes. All right, so let's try it again with AI. Again, I don't have any creative ideas of placing these ships, squares. And we got an exception here. It's an array out of bound exception. And of course, in hindsight, I was so quick, I did not think about the fact that nextInt is likely to generate a number outside of the range of the board. So we need to bound that by the range of the board. And the range of the board is basically those two finite variables in the class board, which are rows and columns. And because those are finite variables, I'm going to expose them publicly. I wouldn't do this for an attribute, but because it's finite, it means it can't be changed from the outside. And of course, this is not private information to keep. It's like a public, it's kind of information. There is no hazard of disclosing it to the outside. So I'm going to make it public so that I don't create two methods for those two attributes. And let's go back to player. And now I'm going to do onBoard dot columns and onBoard dot rows. So that will take care of not going outside of the bound. Of course, the placement may not be valid if the random number happens to return the same column and row combination. So this still needs to be checked. So that's a painful exercise. 4, 4, 5, 5, 6, 6. So this is my own choice, and this is the the board, right? 1, 2, 3, 4, 5, 6, 7 chips placed on the board. All right. So this is getting us very close to deliverable 1 because the two players are placing at the end of that their ships. Of course, I think with a human player, it makes sense to print the board every time so they remember where they place their ships. So that's an easy fix because we can go here and we can do print board after placing. We can do print board or maybe before placing. So I'm going to do onboard dot print so that each time we're doing this, the board is printed, we place, it prints, we place, it prints, and so on. All right, so I'm going to stop at this point. As you can see here, we kind of working top down, thinking about the overall structure and um, finishing out or setting up a plan to finish the details um, later on, right? And those details, you can think about finishing them. We've kind of looked at similar uh, strategy to look at validating input in the tic-tac-toe game. Of course, the biggest detail in here is thinking about the ships and the different kind of ships we have and how they are rotated. So I'm going to leave it as is for now. I believe this will give you a good head start to at least go throughout deliverable 1. And that's it for now.